Final psych for semester 2. So it's gonna be chapters 6 through 13. Most of the high point marks are gonna come from 10 to 13 though. Remember, not 11. We did 11 in first semester. So let's just start going through it. Chapter 6, operation of the functions. So in this one, they give us f and g, and they want us to find f dot g. Now I want you to notice the difference between this one, that dot, and this one over here. This is an open circle, and that's a dot. So this is multiplication, and this is a composition of functions. So you plug in one function into the other function. So this wants to multiply. So we're going to multiply the function f and g. So f is x squared minus 4. G is 6 minus x, and this wants to distribute. So 6x squared minus x cubed minus 24 plus 4x. And now rewriting, having the linear coefficient be the highest power, highest degree. And there we go. Now notice that's an x there because the function right here is x. That's all that means. If that was a w, I'd put all w's. Right? That's all it is. Next one, composition functions, one of my favorite problems. So the way this is g of f of 5. So what I do is I always do this part first. Figure out what f of 5 is. So f of 5, so we're just going to plug 5 into the f function. So I get 3. So this part's done for me. Now all we have left is g of 3. So we do that and we're done. So we're going to plug 3 into the g function. 3 squared minus 5 is 9 minus 5, which is 4. 3. If f of x equals 3 minus x and g of x equals x squared minus 4, find g of f. So this one, now notice there's no value there. So we're just going to get an equation for this one, a function. We're not going to get a value like last time. So we want to plug f into g. When I do this, I always tell myself, okay, what's g? G is this guy. So g looks like something squared minus 4. Now what are we plugging in? F. So we're going to plug 3 minus x squared. So now it's 3 minus x squared minus 4. Now we got to simplify 3 minus x squared. Now keep in mind, it's not 9 minus x squared. I hate that. Right, you just have to multiply by itself. Then you distribute 9 minus 3x minus 3x plus x squared minus 4. Simplify like terms. And we get this. So those go together, this goes together. You get x squared minus 6x plus 5. So that's what g of f of x is, that function. Next one, find the inverse of g of x, which is this. So remember, when you find the inverse, all you gotta do is switch x and y, and then solve for y. Well, I have g of x now, so let's rewrite that to y. Y equals negative 2x plus 4. Then we're going to switch x and y. So we get x equals negative 2y plus 4. Then we just got to solve for y. So subtract the 4. Divide by negative 2. Then we get y equals x minus 4 over negative 2. You can also separate if you want. Now again, that is correct. That's the inverse. But you probably want to write it with the inverse notation. G of negative 1 power equals x minus 4 over negative 2. So that's proper notation. Next, let's simplify this thing here. So I got to find the fourth root of 16, which is just 2. 2 times 2 times 2 times 2 is 16, so 2. Alright, if you're not sure, you can break down 16. You get 2 to the fourth. So the fourth root is just 2. Now remember, the way you do a power is you divide it by the power. So x to the fourth divided by 4 is just x to the first. Y to the 8th divided by 4 is just y squared. And there we go. Next one, it's negative 64 to the third power. Do that a little separately right here. So the cube root of negative 64, which now is negative 4. 4 times 4 is 16 times 4 is 64. So there we go. Now the powers, a is 6 and b 7. Just like before, we divide it by the root. So for a, we get a squared. For b, we get b divided by 2 is 3 with a remainder of 1. That remainder has to stay inside the radical, so that's going to stay inside. Everything else is on the outside. We just have the cube root of 1 more b. That didn't get to come outside. That's how you simplify it. Break down the numbers separately. In this case, we got lucky, it was just negative 4, and then break down the variables. solve. Okay, so I'm gonna take the take the 4 power to both sides first to get rid of that radical. So 10k plus 1 equals 3 to the 4th, which is 81. Subtract 1. So I get 10k equals 80. Divide by 10. I get k equals 8. So there we go. Next one, we got to solve this one. Now, generally, when we do inequalities, you want to make sure that you know what the domain is. So my domain here is 3t plus 6 is greater than 0. And that's the case because as a radical, you can't be great. You have to always be positive, so it's greater than 0. Greater than equal to 0, actually, would be my domain. So that's my domain. And then we solve it. I subtract 6. 3t is greater than equal to negative 6. Divide by 3. So t is greater than equal to negative 2. So that's our domain. So no matter what answer we get, we have to be greater than negative 2. Then we just solve it like normal, so subtract 2 from both sides. I get 3t plus 6 is greater than 3. Let's go to the radical. 3t plus 6 is greater than 9. Subtract 6. 3t is greater than 3. Divide by 3. T is greater than 1. Now in this case, my domain actually has no didn't really affect my answer because I already have t greater than 1. So like we drew a number line going this way, and then here's 1 going this way. So 1 covers it. So that's just your answer. T is greater than 1. Chapter 7, logs and exponential functions. So this first one here, you can't get the same base, right? When that's a that's the thing, you just want to try to get the same base. So 64, that is 2. Now I don't want to do 4 because 32 can't be a power of 4. 64 could be a power of 4, but 32 can't. So that's 2 to the 5th, 6 actually. 2 to the 6th, and then 32 would be 2 to the 5th. Right, so you want to get them to be the same base. So 64 is the same thing as 2 to the 6th, 32 is the same thing as 2 to the 5th. Now once you get the same base, since they have the same base, you just worry about the powers. And you have 6x is less than 5 times x plus 2. Don't forget to distribute the right side. Come on. 5x plus 10. Subtract the 5x. And we get x is less than 10. That's our answer. No domain on this one because it's all real numbers, your domain here. Last time we did a square root where the domain was everything greater than equal to 0. An exponential function is all real numbers, so no domain to worry about. There you go. This one, log base 2 is 16. So the way I do this, I always think 2 to what power is 16. That'd be 2 to the 4th equals 16, so 4. Alternate way of doing it, you could just always, this way I used to do in high school. Set equal to 0, start at x I should say, then I rewrite it. 2 to the x equals 16, and then I try to get the same base. So you're doing the same thing, just a longer method. And x equals 4. So either way you want to do it, whatever's more comfortable for you. For me, it's easy to think, okay, 2 to this power, this to what power equals this guy. So 2 to what power equals 16, it's 4. Log, gotta solve a log problem. Remember, the first thing to do here, you cannot get rid of the bases yet. You gotta condense it. So plus in logs means multiply. So this is gonna be log base 3 of a times a minus 8 equals 2. Now we get rid of logs, like the way we always get rid of logs. So take the base to both sides. So these cancel out, and you get a times a minus 8 equals 3 squared. Distribute a squared minus 8a equals 9. Set equal to 0. A squared minus 8a minus 9 equals 0. Then we want to factor. Two things that multiply to get negative 9 but add to get negative 8 would be a minus 9 and a plus 1. Split. A minus 9 equals 0. A plus 1 equals 0. A equals 9. A equals negative 1. Now the thing about logs, when you sub them back in, your value cannot be negative, so 9 is fine. I get 9 and 1, it's all good. Negative 1 though, when I plug in, I get negative 1 and negative 9, not good. So no answer there. All we have is a equals 9. Next one is a natural log problem. I gotta solve it. So we want to get rid of the natural log, and the way you get rid of it is you take the e to both sides. So you get x plus 2 equals e to the third. Subtract 2 from both sides. X equals e cubed minus 2. So there we go. Rational functions. Remember the key rational functions, especially right here when you have to simplify them, is factory. So the first step you want to do here is factor this. These both have a 6. So if I just rewrite this so we can see a little better, I get that. I get 5, 10 over 8 plus 2. Now anything on top and bottom can cancel. So like top and bottom, diagonally top and bottom, along the top and bottom you can cancel it. These two are exactly the same, they're gone. 5, 10, you can just multiply now and reduce, but I'm going to simplify here. 10 and 5 reduces. I could divide both by 5. So this is 1, 2, sorry. This is a 1. And all we're left with is 12. Write an equation to find the vertical asymptote. All we got to do for that is set the denominator equal to 0 to get the vertical asymptote. So x minus 2 equals 0. So x equals 2. Vertical asymptote. Horizontal asymptote, that's a little trickier. You look at the powers. Top bigger than the bottom is none. Slant if it's only 1, but we don't do that. Bottom less than top. Bottom bigger than top is y equals 0. And if they're the same, it's the ratio. In this case, these powers are both the same, so we take the ratio of the two things. X over x, which is just 1. So y equals 1. Horizontal asymptote. They want us to divide these. So remember, when you divide, you flip the right hand side. And then you just multiply. So y over x squared minus y squared times x minus y over y squared. Then just like before, we got a factor. So we could factor this guy to x minus y, x plus y, difference of two squares. And then remember, anything on top and bottom can cancel out. So x minus y, x minus y. And then y with y squared. Look what's left over. On top, all we're left over is with a 1. A lot of people leave it blank. It's like, no, there's 1 on top. 1 times 1 is 1. On the bottom, you have x plus y times y. So y times x plus y. And you could leave it like that. I guess some people might want to simplify it. To me, that's uglier. This is just fine. Chapter 10, sequences and series. So here's the formula for arithmetic sequence. Write an equation for the nth term of arithmetic sequence. Hey, if we use the formula, un equals u1 plus n minus 1 times d. Right, remember u1 is the first term, d is the common difference, n is the term number, and this is the term we're talking about, or the value of the term we're talking about. So we want the nth term. So you just want, all we want to do is simplify u1 and the common difference d. Well, u1 is here, and the common difference, we're adding 6 every single time. So there's my d. So negative 3 and 6. Let's simplify that. Distribute, I get negative 3 plus 6n minus 6. Add like terms. And the general formula is negative 9 plus 6n. Or 6n minus 9 is probably a little nicer. Remember, if you want to find any term, like what's the temp term, you just plug in 10 for n. Next one, given the arithmetic sequence 4, 9, 14, 19, 44, 114, find the number of terms in the sequence. So number of terms. So we're just going to go back to our formula. And now we have more things. We still have u1. We still have the common difference is 5 now. And now we have un. Right, so we're trying to find n, but I have everything else. So I know this is 114. I know this is 4. And I know this is 5. So 114 equals 4 plus n minus 1 times 5. Let me just solve it. I like to subtract 4 first. So 110 equals 5n minus 5 plus 5. 115 equals 5n divided by 5. I get 23, and equals 23. Find the 20th term in the arithmetic sequence in which a1 equals 3 and d equals 3. Well, let's find the formula first. First term is 3. Common difference is 7. So here's our formula. And then they just want us to plug in 20. I think when I picked this problem, I thought it was going to be a little more difficult. So it's fairly simple. Plus 19 times 7, which is about 133. And then plus the 3 is 136 is the answer. So that's the 20th term is 136. Okay, a couple of my favorite problems. Use the binomial theorem to find the third term of the expansion. So remember, third term of expansion, you gotta know how this works. The first term of expansion is always 6 to the 0, or the whatever power it is over 0. The second term will be 6 to count up, 6, 1. Third term will be 6, 2. So that's the one I want to look. So we gotta expand 6, 2. So we always write the same thing. So you write 6, 2, and then the first term, n, and the second term, 2p. Now we gotta find all the powers. Now the first power is easy. The whatever the bottom number matches the power of the second guy. So there we go. If that's a 2, that's a 2. And then to find this guy, this power plus this power has to be this power. So 2 plus blank equals 6. That would be 4. And there we go. So now all we gotta do now is simplify this. So we'll start here. 6, 2. There's 2 ways to do it. You could put in your calculator 6c2. So I have a calculator over here. If I want to go on 6 math probability and CR, I'm doing a combination, and then 2. So I get 15. Or you can use the formula, which is top factorial over the bottom factorial. Then you subtract the 2. 6 minus 2 is 4 factorial. Remember the way you simplify factorial, you just do the top number until you get to the highest number at the bottom. So 6 times 5 times 4 factorial. All over 2 times 1 factorial. You always expand the shorter one. You can leave the bigger one alone. That should cancel out. That's always the idea. Expand the top one, 6 times 5 times 4. Why did I stop at 4? Because that's what the biggest number at the bottom is. Leave it there. And then this guy you expand out. So 2 times 1. These cancel. You get 30 over 2, which is 15. So either way you get 15. So if you do by hand, use the calculator or Pascal's triangle. The rest we just simplify. N to the 4th, which is n to the 4th. Negative 2p squared. So now this 2 goes with both of them. Very important, right? It's negative 2p times negative 2p. That's what's going on. So it's 4p squared. And then all these get multiplied. So that's what's going on here. You're multiplying all of them. So I'm going to get 60 n to the 4th p squared. And that'll be the answer. That'll be the third term of this expansion. Now we use the binomial theorem to find the x to the 10th term of the expansion of this guy. So this is a little different. They don't tell you what term it is. They want to know the term that happens to have x to the 10 in it. So what I do here is I start off the same way we always start off, right? It's 7. I don't know the bottom yet, so I'm going to leave it blank. Then we do the first term, x squared. And then we do the last term, negative 2. So this is how all these things start off. This time I don't know what the bottom power is, which means I don't know what this power means, which I don't know what this power is. But they do tell us something. We want x10. Well, here's my x. What power does it need to be to get 10? Well, power to power you multiply, so this has to actually be 5. Because then when I multiply these together, I'm going to get x10 down here. And that's all I need. Once I know that's 5, everything else just works out, right? So this power plus this power has to equal 7, so it makes this 2. And if that's a 2, right there's a 2. Now what I gotta do now is simplify the rest of this. 7c2, I'm going to just do it by hand this time. So 7 factorial over 2 factorial, and subtract them, 5 factorial. You expand the top, so you get to the bottom one. Always expand the smaller one, and then leave the bigger one alone on the bottom. These cancel out. I'll reduce these two, that's 1 and 3, and I get 21. And then over here, it's negative 2 squared, which is positive 4. So I get 84 x10. Now technically it says coefficients, my answer should only be the coefficient, which is 84. But I want to mark you down if you left the x10 there. Now we're off to the trig stuff. Find the value of tan theta. So tan of theta right here, opposite over adjacent. So this is opposite, this is hypotenuse, this is adjacent. So tan of theta would be 4 over 3. And that's it. Solve for x in this guy. So I do want to do the same thing. You want to highlight your angle, list the sides. This is opposite, this is adjacent, this is hypotenuse. Now the only ones we have values are opposite and hypotenuse. So you gotta go like SOHCAHTOA And which one we're using here? We're using O and H, so that's so. So sine of 60 equals 4 over x. Right, so then all I do here is solve for x, so multiply by x and then divide. So x sine of 60 equals 4. X equals 4 over sine of 60. And I would leave it like that. You can also put in your calculator and get rad 3 over 2, which would make this 8 over rad 3. Or some decimal, but this is also fine. What is the coterminal with the 90-degree angle and center position? So remember, coterminal all means it's the same angle position, but you went around in a circle. So all you do is add or subtract 360. 2 pi for radians. So 90 plus 360 be 450. So there we go. And actually, we could keep on adding 360 if you want a different version of the answer. Or if you want to go backwards, keep on subtracting 360. That'll get me negative 270. So again, all these works, and there's also a lot more. You keep on just adding and subtracting 360 to get more answers. Find the exact value of sine of 5 pi over 4. So if you know me, I like to draw a triangle. Here's 0, here's pi. 5 pi over 4, always make, this is my trick, make that 4 over 4. I'm going to do it in black. So we're going a little bit past there, right? So that's pi, so you make it 4 over 4. 5 pi would be a little bit past that, so be in quadrant 3. It's over 4, so I know it's 45, which means I know the sides. 1, 1, rad 2, right? 45, 45, 90 triangle. 1, 1, rad 2. 30-degree triangle. 1, rad 3, 2. Hypotenuse is always 2. And a 60-degree triangle. 60 is the biggest angle. So rad 3, 1, and 2. I know these two are the same triangle. I just like to keep them separate. It makes it easier for me. And then we do sine of this. And actually, I'm a little off. We went to the left, so this should be negative. And we went, oops, sorry. And we went down, so this should be negative. Hypotenuse is always positive by default. So sine would be so. Here's my angle, so it'll be opposite of hypotenuse. Negative 1 over rad 2. Or if you want to rationalize it, negative rad 2 over 2. Remember the period of the following function. Well, the period, so we want to start somewhere. Let's start right here. I want to do one complete rotation. So how long it takes to repeat itself. So it goes down, then it goes back up, then it just starts doing the same thing. So my period here is going to be 4. The highlighter was lackluster. Right? That's my period. Just 4. That's how long it takes to repeat itself. There we go. Next one, graph y equals 4 cosine 2 theta. So let's figure out stuff first. My amp is 4. That's how high you could go. So I go all the way up to 4. And I go all the way down to negative 4. My period is 2 pi over b. So in this case, 2 pi over 2, which is just pi. So that's how long it takes me to repeat myself. So if I start at 0, I could go to pi. And if I do another rotation, I could go all the way to 2 pi. So this is my basic graph going to be in this little box right here. And then we just graph it. So remember, a sine graph starts at the origin, ends at the origin, halfway between is where you cross, between these two is your highest, between these two is your lowest. And I was about to do that and then realized this is actually a cosine graph. So it's the one we need. So remember, cosine graph starts at the amp, ends at the amp, halfway is lowest, and in between those two, these 2 points is my midline. It's kind of like that. Again, if you won't go into the same graph, just the way you want to see it. Like right here's the start of the cosine graph. But so we're doing cosine, we're going to start at the amp. So we're starting here at 4, end the same spot, halfway is my lowest, in between these two is my midpoint, between these is my midpoint. Just going to graph it. Should be curvy, something like that. Not my best graph, but whatever. And if you want to do another rotation, this one doesn't ask you for another one, but sometimes I do. So just be prepared. So you get that. So that's a basic one. Now let's go to the more advanced one. Right, this one has a vertical shift, a phase shift, and then like a different amp. So let's do the vertical shift first. Vertical shift is 3. So remember, that's like the new middle. So always think about it. It's the new middle. So at 3, 1, 2, 3, that's my middle, my new middle now. My principal axis, some people call it. And then let's look at the amp in the same direction, right? My amp is 2. So that means that for my middle, I can only go 2 up, which will give me 5. I could go 2 down, which will give me 1. So my highest I can go is 5. The lowest I could go is down to 1. So like that's the highest and lowest my graph's gonna go. So go up to here, go back down again. But now I gotta talk about the phase shift. Or let's talk about the period first. Period is 2 pi over b. There's no b in this case, so just 2 pi. Phase shift, how much to move left and right. And it's that opposite, so it's gonna be -2. Negative pi over 2, sorry. So that's where we're starting. Let me do a different pen. I'm gonna start at negative pi over 2. We're starting right here. So that's where we start, and then where do we end? Well, it takes me 2 pi to end, so it's going to take me 2 pi to end. Where is that at? Just add it to the start point. Do a common denominator. So I get 4 pi. So negative pi plus 4 pi would be 3 pi over 2. So that'll be right here's where it ends. So this box right here is my graph. It's going to start right here and right here. Let's do it in red because it's easiest to see. We're doing a sine graph, so we start at the middle. And at the origin, halfway between those two is my highest, halfway between these two is my lowest. So that looks kind of like that. And then it keeps on going, and it keeps on going. So there's the sine graph all moved around. Chapter 13, trig identities. I'll give you all the identities right here. So the sine row, cosine row, area of a triangle, identity for your tan, and the Pythagorean identity. So this first one here, all we want to do is simplify this. So again, my general rule is keep sine and cosine, change everything else. So tan, I'll change that to sine theta over cosine theta times cosine theta. These will cancel out because that cosine's over 1. You just get sine. There you go, all simplified. Next one, sine plus cosine over tan squared. Sine squared plus cosine squared over tan squared. Well, that's right here. Sine plus cosine squared is 1. 1. So I get 1 over tan squared. Remember what that is? You could flip it and it becomes cotan squared. Next one, it wants to solve this equation. So the key here is you want to get sine by itself. So we're going to add rad 3 to both sides to solve like normal. 2 sine theta equals rad 3 divided by 2. Sine theta equals rad 3 over 2. And then I just graphed it. So like go backwards. That's the answer. What's the question? So work backwards here. Here's 0, here's pi. Sine is positive. So if I'm doing all students take calculus, remember sine's positive at A because they're all positive A. And then S. That's what S stands for, sine. If that's where sine's positive, it's negative down here and here. Now our answer is positive. So I'm going to draw my triangles in quadrant 1 and quadrant 2. Oh, then what's next? Well, it's rad 3 over 2, right? So sine, SOHCAHTOA, opposite of rad hypotenuse. So I know my opposite is rad 3. And my hypotenuse is 2. And just right there, I should know what angle that is. Right? What's opposite of rad 3? Rad 3 is the biggest one, so that's 60. 60 here also. So this angle right here will be 60 degrees. The angle right here, if we're talking about degrees, I'll do degrees first. Here's 180, right? Because straight line's 180, and then you go 60 back. You haven't got there, you're 60 away. So minus 60, 120 degrees. So those are my answers in degrees. Now, I generally don't care, but in this case, it does say radians, so I probably should do it in radians. Let me erase a little bit of this so you can see the radians. So the way radians works, you just have to memorize what's 60 degree in radians. It's pi over 3. So this is pi over 3. Then if this is pi, and we're talking about pi over 3, this will be 3 over 3. And you're a little short, so 2 pi over 3. So if we're doing in radians, it's pi and 2 pi over 3. So either one. Next one, solve cosine theta times 2 sine theta plus 1 equals 0. So we're going to split it. Cosine theta equals 0. And 2 sine theta plus 1 equals 0. Now solve each one separately. So cosine theta equals 0. That's on the unit circle. Anytime sine cosine equals 1 or 0, it's on the unit circle. So 0, pi, pi over 2, 3 pi over 2, 2 pi. So again, you gotta remember the points. And the points are 1, 0. It's like normal xy. You went to the right, so x is 1. You go up, y is 1. You go to the left, -1, 0. You go down, 0, -1. Then you gotta remember, what is cosine? Sine or cosine? We always say sine e is for y, sine e. So cosine is the x. Sine is y, cosine is the x. So where does x equal 0? Right here and right here. So my answers are pi over 2 and 3 pi over 2. And then we gotta solve 2 sine theta plus 1 equals 0. So solve for sine. Sine of theta equals -1/2. Subtract 1 divided by 2. Then we just do it like before. Here's our table. All students take calculus. This time we have a negative sign, so we're going to be in the bottom. Same idea. Sine is so opposite of hypotenuse. So -1, -1, 2. And then since it's -1, the opposite side, right? So what's opposite -1? That is, or 130. It would be 45 if it was 1 and rad 2, but since it's 1 and 2, it's 30 degrees. This is 30. So as in degrees, this would be 180 plus 30, which is 210, and then all the way around is 360 minus 30, which is 330. But since this is in radians, I'll keep it all in radians. So if I was doing radians, you gotta remember what's 30 degrees in radians. It's pi over 6. So that means this is pi, so you make it 6 over 6. And then we go one more, 7 pi over 6. This would be 12 pi over 6 when you go all the way around, and then one less, 11 pi over 6. And put my answers over here, I get 7 pi over 6 and 11 pi over 6. So 4 answers for that one. Okay, last few. Find the measure of angle C. So we have triangles here. There's law of sines, law of cosines. So remember, if it's pairs, law of sines. If it's not no pairs, law of cosines. So measure of angle C. I think I said 6 earlier. Look what you have. I have a pair. I have this angle and the side opposite it. So it's law of cosines. So I'm gonna do A over sine of A equals C over sine of C. So it's gonna go 29 over sine of 82 equals 20 over sine of C. Then you cross multiply, and I get 29 sine C equals 20 sine 82 divided by 29. Sine C equals all that mess. I'm going to put that all into the calculator. Bring my calculator back up. Now keep in mind we have to be in degrees for this. This is all in degrees. So I'm going to go to mode, make sure I'm in degrees. Okay, I can get out. And let's type this all in. 20 sine of 82 divided by 29. So I get 0.8682. And then to get rid of the sine, we're going to sine inverse both sides. And I have a calculus right here. So second sine, let's get our answer. And I get 43.1. C is approximately 43.1 degrees. Right, because we did sine inverse of both sides. I probably should show that. Just like that. So there we go. Next one, find the area of triangle ABC. Let me rewrite it so you can kind of see it beforehand. There's not gonna be that much space. So in the formula sheet up there, it tells you the area equals 1/2 AB sine of C. Now, the key thing with this is that it's 2 sides and the angle between. And even before we start doing any work, I have 2 sides and angle between. I have this side and the angle between them. So this is just going to be 1/2 24 20 sine of 82. So it has to be 2 sides and the angle between. Then you just put that in your calculator. So 1/2 times 24 times 20 times sine of 82. Which gets me a 237.7 approximately. units squared. Now let's move on to the last question. So they want us to find the measure of angle A. In this case, I have no pairs. I have no angles at all. So I can't do log sines. I have to do log cosines. Now there's two formulas for log cosines. Right, there's this one, generally easier one to find a side, but it works for both. Probably this one most people think of. And then there's this form which is a little easier if you want to find the angle. I'm going to use that one because it's a little easier when you want to find the angle. So that formula is, so I'm doing here, cosine of C equals a squared plus b squared minus c squared all over ab, 2ab. There we go. So that's the formula. Now the key thing here is that c is the only thing that matters. C is the angle you're looking for. So in this case, I'm looking for angle A. So in my head, I just go, okay, well, this is really just A, and that is A, and then these are, I guess, my C's. So because these two things don't matter. These are just the other two sides. What matters is what you're looking for. I'm looking for angle A, so that's an A. It makes that guy an A. The rest is just the other sides. So in this case, I have cosine of A equals the other two sides, so it would be 17 and 11, minus opposite angle I want, so opposite of A is 10 squared over 2 times 17 times 11. Like that. I'm going to put that into the calculator. So the easiest way to do that is to put alpha y equals, let's put the fraction bar. 17 squared plus 11 squared minus 10 squared all over 2 times 17 times 11. And you get that, or the decimal version of that. And then just like before, we're going to do cosine inverse both sides to get our answer. A is approximately, let's do the cosine inverse. Get our answer. 34 degrees. So there we go. And that's the study guide.